Hello everyone, how are you? There was some technical delay. Let's start the lecture. Myself Virendra Kumar and you are watching Hira Cosmos. So students, in this video lecture we are going to discuss the properties of matter, and regarding that we'll discuss the hydraulic stress and strain, which I had discussed briefly about this. I will derive some relation for the hydraulic stress and strain for the spherical shaped body or sphere. So let's begin. So I have told you that hydraulic stress hydraulic stress is equal to the pressure due to the liquid in which the body is. So that may be the pressure P or maybe force per unit area, restoring force per unit area, right? And hydraulic strain is equal to change in volume upon initial volume, right? So yeah, so here I would like to attract your attention that this hydraulic strain is always negative when there is a hydraulic stress over the object that is dipped in the liquid. So see, if there is a pond filled with the liquid, that is water, and there is a ball inside this. So ball is feeling the pressure due to the water liquid, and due to the pressure by the liquid, the ball is getting contracted due to the pressure. That means its volume is getting shrink, decrease. So here decrease means the initial volume. Suppose if initial volume was V and the final volume was V prime, that is decrease means V minus delta V, right? There is a decrement in the volume. So here V is equal to plus minus delta V. That's why hydraulic strain is negative, right? So hydraulic strain delta V by V will be negative in sign, right? So this is clear up to here. Now let us derive a basic formula for hydraulic strain that may be important for your examination point of view. So focus here. Suppose a sphere of radius capital R is inside the liquid that is applying external pressure, external pressure, that is applying external pressure over the sphere, right? So due to this, the size of the sphere will reduce, decrease, and if size is decreasing, that is because of the change in the radius, that is decrement in the radius of the sphere. So that means if due to this pressure, that is hydraulic pressure R changes to R prime, then R prime will be less than R, right? So suppose R prime is equal to R minus delta R. So we have to calculate the hydraulic strain. So hydraulic strain is equal to change in volume upon initial volume of the sphere here in this case. So you know the volume of the sphere whose radius is R. By the knowledge of class 9 10th mensuration, we can calculate the volume by formula 4 by 3 pi r cube. So this is the initial volume. This is the initial volume, right? Now suppose, so initial volume is equal to 4 by 3 pi r cube, and final volume that is equal to 4 by 3 pi r prime cube. And here you must note this V prime is less than V because of the hydraulic pressure getting applied on the sphere due to the liquid. So V prime will be always less than V, right? So if you have doubt, you can ask. So up to here, I hope it is clear. So V prime is less than V. So change in volume. So change in volume, I think this color is not properly visible. Change in volume. Change in volume. Change in volume is equal to what? V prime minus V, right? So V prime is equal to V 4 by 3 pi R prime cube minus 4 by 3 pi R cube. So 4 by 3 pi is common out, R cube, R prime cube minus R cube. See. So this is the change in volume, and that is equal to delta V. You must note here that R prime is less than R because the sphere is getting shrink. So R prime must be less than R. So this value is going to be negative. Mind it. So our hydraulic strain will be given by hydraulic strain for sphere. Hydraulic strain for sphere or spherical shape body is given by delta V upon V, and that delta V is equal to 4 by 3 pi r prime cube minus r cube upon original volume of the sphere, that is 4 by 3 pi r cube. So this is going to be cancel out. So what we are left with, r prime cube minus r cube upon r cube, that is equal to r cube upon r prime upon r whole cube minus 1. So see, our hydraulic strain in case of sphere, in case of sphere is this much, r prime upon r to the power q minus 1. So it may be asked directly by giving the radius of the initial sphere and the final sphere, and may ask that find the hydraulic strain. So if you know this relation, you can do this by just substituting the values, right? Otherwise you have to follow the whole process. So this is trick for the calculating the hydraulic strain for the sphere. So you can see here r prime is less than r. So this value is going to be less than 1. So definitely this total value will be negative. So hydraulic strain is negative, right? So let's proceed further in this. So hydraulic strain, and this is the strain. So you know that any kind of strain, whether it is longitudinal strain, whether it is a shearing strain, or whether it is a volumetric strain or hydraulic strain, it is the dimensionless quantity, unitless quantity, physical quantity. And here in case of volumetric strain, that is the hydraulic strain is negative, right? Why I am focusing this negative value? Will utilize this concept in the next section. So here Hooke's law. So you know Robert Hooke is a famous scientist who have done in a different area, whether it is astronomy, geometry, biology, and in our case, physics case, he is known, he is remember for the elasticity. He has contributed in the physics a lot, but here in this chapter we remember him for the Hooke's law. Hooke's law. What is Hooke's law? Not Hooke's law. So he gave a famous law by doing experiment. This is not the theoretical concept. This is the empirical law. See, this is the empirical law. In NCRT textbook, in your NCRT textbook, it is clearly written. It is an empirical law. By air, sorry, by air and trial, he has he has established this law by doing practical, by doing experiment on different material. He established this law. So what is this law? So as per the Hooke, he stated that under the limit of elasticity, or elastic limit. Under the limit of elasticity, applied strain applied stress is directly proportional to the strain produced in the body or the material. So this is the law of Hooke's. Stress is directly proportional to the strain, and we know that stress and strain, there are three different kinds of stress, and there are corresponding strains, right? So stress is directly proportional to strain provided the stress is that much that is not going to deform the body permanently. That means we are applying the stress within the elastic limit. Then this Hooke law is applied. Then this Hooke law is useful. Then the material will obey the Hooke's law. If we are violating this constraint limit of elasticity, then Hooke's law will fail. राइट सो आपको क्या मानना है आप ये हुक्स लॉ इज यूजफुल इज ओबेड ओनली व्हेन द स्ट्रेस इज अंडर द limit of elasticity, right? So if we remove the proportionality, then we get the constant, that is stress is equal to some constant into strain, and this constant is known as the modulus of elasticity. See, so K is the modulus of elasticity. Modulus of elasticity. Please remember these terms. These are going to be frequent coming terms for this chapter and further topics. So K is the modulus of elasticity, and Hooke's law is the linear relationship between the stress and strain. Linear relationship between the stress and strain, right? Linear relationship. Provided the provided condition is elastic limit is obeyed. Elastic limit is respected until we are under the elastic limit. This stress is directly proportional to strain, that is stress strain relationship is linear here. So and there are some materials which do not exhibit this linear relationship. So this linear relationship, this is the, so for this case आप लोग देख रहे हैं ना, हाँ. So for this case, बच्चों, you can write some comments so that I can know that you are watching. Otherwise, I just by seeing the number that you are watching, I don't feel that who is watching, who is not watching, right? So please do some comments so that I can get to know. So limit of elasticity, stress strain relationship is linear. So Hooke's law is linear relationship between stress and strain for the material who is elastic. and the stress is under the elastic limit. But there are some material which do not follow the Hooke's law, do not obey the Hooke's law, and they are called the elastomers. They are called the Here it is mentioned that there are some materials which do not exhibit the linear relationship. So elastomers, ये इंपॉर्टेंट पॉइंट है, आप लोग नोट करना. Elastomers are those materials, they are elastic. They are elastic, but they are not following the Hooke's law. What is Hooke's law? Hooke's law is the linear relationship. That is, stress is equal to some constant into strain. There is no non-linearity for the Hooke's law, the material who is following the Hooke's law. But there are certain materials which do not follow the Hooke's law. So they are called the elastomers. They may be polymers. They may be viscoelastic material. So elastomers means rubber. Elastomers means material that is rubber. Some polymer is different. Some heart aorta 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 no, you know that is the heart arteries, huh? Heart arteries, aorta, that is highly elastic but doesn't follow the Hooke's law. That what does it mean? That so for the elastomers, Hooke's law is not obeyed. Hooke's law not obeyed. Right. So that means in this case stress stress and strain. So so non-linear relationship or non-linearity. ठीक है. So mark it. For elastomers, stress and strain show non-linearity. Doesn't follow the Hooke's law. They are not linear. So linear non-linear का मतलब क्या है? मुझे उम्मीद है कि आप लोग समझ रहे होंगे. Otherwise, I would draw some graph for you who doesn't know. Linear means if we plot, this is y-axis, this is x-axis, and this is origin, and if we put stress along the y-axis and strain along the x-axis, then for linear relationship, so yeah, so for the linear relationship, I am using this line for the perfect straight line. So yeah, so for the linear relationship, there will be the straight line. If we plot the stress versus strain graph, then we will get the straight line. And if it is not linear, so there will be the curve in place of the straight line. Okay, ठीक है. Okay, so this is the Hooke's law, right? So there are certain materials which do not obey the Hooke's law. ये एग्जाम में आता है, आप लोग को जानना चाहिए. नीचे आपको दिखाता हूं, पहले उसको देख लेते हैं और फिर उसके बाद स्ट्रेस स्ट्रेन कर्व को हम लोग डिस्क्राइब करेंगे. ये देखिए, ये देखिए, ये जो है आपका ग्राफ है, ये है ग्राफ स्ट्रेस वर्सेस स्ट्रेन फॉर द आयोटा. हार्ट इलास्टिक टिश्यू ऑफ द आयोटा। आप समझिए, जो है हमारे जो हार्ट के अंदर जो ब्लड लेकर जाती है, तो उस नली को आयोटा कहते हैं। वो हाईली इलास्टिक होती है और बहुत ज्यादा स्ट्रेच होने की कैपेबिलिटी रखती है, बट हुक्स लॉ को फॉलो नहीं करती है। इसका ये मतलब नहीं है कि जो मटेरियल हुक्स लॉ को फॉलो नहीं करता है वो इलास्टिक नहीं होगा, ऐसा नहीं है। बट इट इज showing the it is not following the Hooke's law and showing the non-linearity relationship between stress and strain। इसका मतलब क्या हुआ? नॉन लिनियरिटी रिलेशनशिप का मतलब क्या हुआ, फिर से समझते हैं। नॉन लिनियरिटी रिलेशनशिप का मतलब क्या हुआ? नॉन लीनियर, फिर से समझते हैं, वी विल अंडरस्टैंड अगेन।